Yeah, the Book of Evil is where we are addressing these problems from today. Uh, the Book of Evil is any physics textbook that is this big. Anything that is this thick of a textbook deserves to be called the Book of Evil. So, no, this is not literally Yell's book. Yell's book is just as equally bad. So that's why I just don't give it to you guys. Um, there's, yeah, yeah. Okay, there are two towers. This is going to be like a Lord of the Rings movie. There are two towers here. Uh, everything breaks down here though. So there's a cable that is holding an object between these two towers. The angle of one of them is 26 degrees. The angle of the other one is 15 degrees. Yeah, not 26 degrees. Yeah, they're not the same, right? So you've got 26 degrees on the right side, and you've got 15 degrees on the left side. Okay, and these are just like radio towers or something. I don't know. There you go. Do, 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 do. Yeah, I don't know. Says, oh, they're. I'm sorry. They're. It's an amusement park ride. They're suspended from a tower by a long cable. So like, this is what happens after you launch them off the ground. I don't know. Let's see here. So it basically it starts them off at the top and then it drops them down. Let's see. The lifting cable is released and the riders swing down the circular arc. If the four riders have a total mass of 270 kilograms, what are the tensions in the two cables just before release? So we know that the mass of the object is 270 kilograms. It doesn't matter if there's four people in there. That's still 270 kilograms combined. We're not going to make free body diagrams for everybody. We're just going to say all four of those people and the cart and the assembly together, all of it is 270 kilograms. That is a it is a system. Okay, you can include the cart if it makes you feel better. You can include the mass of the cart too. Okay. Do I need to go through this with you guys, or do you need to do this on your own? You can do this on your own, right? We're looking for the tension in the two ropes. So why don't we call the one on the left T1, and why don't we call the one on the right T2? We know they're not going to be equal to each other. Y'all just said that. So I think the way that they described the ride is that it's going to like they start off in the bottom left and it picks them up. The one on the right picks them up, and then after it picks them up a certain distance, it just drops them. So they'll drop, but the T1 will stay taut. So they'll move down like this. In this case, though, we're not particularly interested in the route that they travel. It's going to kind of go like this. Okay, so the ride this there's like a winch on this side and the winch picks it up and then once they get to this position, it just like lets go and they just wee down this way like a big swing. Now, from an engineering standpoint, this sounds like an absolutely terrible idea. You don't really want to make a ride that right, you don't want to smack a tower, but this is uh this is okay. This is a physics problem. Okay? What would we do first? Okay. Not crying. Next one. Free body diagram. Okay. So yeah, there is a force of gravity on the mass, and it is not 270, 2,700 newtons. That's fair. That's fair. Okay. So we have a force of gravity going down. What else do we have? Okay, we have two tensions. Okay, one is going this away, and we'll call that T2, and one is going this away, and we'll call that T1. I'm going to try to make it look thinner than the other one because it's at a smaller angle. That's T1. Okay. Um, what next? Okay. So I like to make red the x direction and green the y direction. So I'm going to go red, and then, okay, I'll make blue the Y direction. That's fine. It's fine. I like how I just clicked the blue pin and it didn't go blue. There it is. Okay. All right. So there is an angle here. There is an angle here. Um, this one up top will be T2 sine, very good, T2 sine theta. Actually, I guess we need to call them, why don't I just go ahead and say sine 26, because if I say theta for both, that might not work out so well. So that's T2 sine 26. The one on the bottom is T2, T2 what? Yeah, there's going to be a lot of subscripts. This is T2 what? Cosine 26. Okay. The other one, vertical, is the same way. So this is T1 sine 15. 15. And then we're going to do T1 cosine 15. Okay. Now, can we solve from here? Okay. I'm ready. Okay, so like, yeah, that's a good question. Is it moving? Okay, so no. So that means that it's not accelerating either, right? Okay, so that means the sum of the forces is equal to... I heard the right answer. 0. 0, right? Because they're not moving one direction or the other. And 0 is equal to the mass of the system times the acceleration. It just happens to be that the acceleration is 0. So the sum of the forces is 0 in this case. It's 0 in the x direction and in the y direction. So we have to keep that in mind. It's x and y. So the y direction overall is downward 2,700 newtons. The y direction overall is 0. Right? Right? So I know, and the way that I like to do that is I'll say the sum of the forces in the y direction is equal to 0, and then I'll balance them out to each other. I like to write it this way because if I say that it's equal to 0, I can make sure that all my forces are actually considered in the problem before I accidentally miss one. So how many forces do I have vertically? 3. There's 3. There's T1 sine, T2 sine, and 2,700. Okay, so I'm going to go T1, T1 sine 15, T2 sine 26. And then the 2,700 is negative minus 2,700 equals 0. Okay. So then what I do is I balance them out. Okay, so the 2,700, I'm just going to move to the other side. So T1 sine 15. And if you want, you can go ahead and get numbers for sine of 15 and sine of 26, but I really think that's just too much effort. I think it's just easier to just write sine 15 and sine of 26 than it is to write the decimals out. 2,700. I don't think we can go any further at this point. We have to look on the x direction, before we can go any further in the y direction because I have 2 unknowns and only 1 equation. And if there's one thing I learned in algebra is that if you have more than 1 unknown, you can't solve for it unless you've got another equation to use it to solve with. So I can't go any further here. That's like the only thing I learned in algebra is that if you have more than 1 unknown, that's it. Okay, so okay, and you know that I'm going to do this the old-fashioned way, so I'm going to say the sum of the forces in the x direction is equal to 0. So, therefore, negative T1 sine 15 plus T2 sine of 26 equals 0. It's negative because it's going left. Remember, left is always negative and right is always positive, unless you decide to flip everything on me, and you'll still get the answer right, but it's going to hurt my brain a little bit. It will hurt my brain, but it's doable. So then we get to the, and honestly, guys, if you know that they're equal to each other and you just write like, T2 sine of 26 degrees is equal to T1 sine of 15 degrees, because they are equal and opposite to each other, that's fine. I'm not going to mark off points because you didn't include this part. Okay. Did I do that wrong? Oh, whoops. Okay. Yeah, that's all wrong. Yeah, just kidding. Everything is wrong. Yeah, if you do sine instead of cosine, I will count off points. No, don't go with the flow. You should always be skeptical. Always be skeptical of me. There we go. So the x direction is the cosine. Yeah, we're right now. Okay, so the x direction is the cosine, and those forces balance each other out. So T1 cosine of 15 plus T2 cosine of 26 equals 0. And if you skip that step right there and you just write that these two are equal to each other, that is fine. I just write it out from the beginning of Newton's second law because it's physics class and that's what we start with. Okay. And in all honesty, if you start here on open response questions and you just write like it's not moving, there's no acceleration, so therefore the forces are balanced, that's like partial credit right here. So the reason why I write these out is these are really great ways to get partial credit points without doing any like extra work. Like you don't have to be like, what are we doing here? You don't have to really like think that much harder. It's just, oh, hey, I know that the sum of the forces is equal to 0. And they'll look at that and they'll be like, oh, okay, they know what they're talking about. Okay, so now we can get a relationship between T1 and T2, and decimals are probably going to come out to play here. Do y'all want to solve for T1 or solve for T2? It doesn't really matter either way. T1? Okay, it's going to end up, we're going to get the same answer either way. So T1 is going to equal T2 times the cosine of 26 divided by the cosine of 15, and the cosine of 26 divided by the cosine of 15 is a number. I don't know what that number is. It's a number. I don't know what that number is. We're going to have to calculate it. Make sure that you are in degree mode. Uh-oh. Maybe I'm not in degree mode. I'm in degree mode. Cosine of 26 divided by cosine of 15? What'd you get? 1.93? 0.93. Okay, 0.93. Okay, I'm with you. I did forget my parentheses. 0.93. So 0.93 T2 is equal to T1. Okay, that's reasonable. So now, everywhere that I see a T1, I'm going to put in 0.93 T2. So here's this T2 is going to become this T1, right? I think so. So this T1 is really 0.93 T2 sine of 15 plus T2 sine of 26 equals 2700. From here, sine of 15 and sine of 26, those are actually like numbers. So we're just going to end up needing to multiply them together. And then we can combine like terms. So sine of 15, if I were to put that in the calculator, that comes out to 0.26. Okay, so it's 0.93 times 0.26, which means I get 0.24. Do I get a second on that? If you multiply sine of 15 times 0.93, do you get 0.24? Okay, so that's 0.24 T2, and the sine of 26 is a number. 0.44, yeah. Okay, so we're going to do 0.44 T2 equals 2,700 newtons. So 0.68 T2, the second tension, is equal to 2,700 newtons. We're going to divide both sides by 0.68. And when we divide both sides by 0.68, that gives us our T2. What is it? 3970.6. Okay. 3,970.6. T2 equals 3,970 newtons. Don't worry about the 0.6, it's fine. So we also know that 0.93 times T2 is equal to T1, which means that 93% of T2 is the T1 value. So now that we know what T1 is, we can multiply that to find out what T1 is. So I'm just going to move that. What'd you get? So this T1 value is 3692. Okay, and a second. Newtons. So these are the two tensions in the cables. They're not the same. And let's do a sanity check here. Okay. Does it make sense that the tension for T2 is a larger value than the tension for T1? Okay, because the angle is greater. A greater angle means a greater tension. Okay, fair. Is there anything glaringly out of the ordinary about this? The, the way it is a strange ride, isn't it? It is a very strange ride. Okay, so let's see here. Yeah, since it's being supported, and it's 250 kilograms. Do what? Uh-huh. Yeah. No, you would continue to swing. Yeah. That's another physics question that we're going to handle at a different date. So, if you so tell you what, tell you what. So, since y'all since y'all want to know how many G's you're going to pull, we can answer that question later. So in my notes, I'm going to type in answer later so that if it actually does come back up again, I can just search for it. And if I search for answer later, this is going to show up. It'll show up the page so I can actually just like find it. Unless you've got some like weird code y'all want to go with and search for it that way. You want to search in Big E Cheese? If you search Big E Cheese, then you'll find it, unless you start spamming my notes with it. Big E Cheese. There you go. Good job. Okay, so like, he's gonna remember Big E Cheese. He's gonna remember it. He's gonna remember Big E Cheese. Yeah. So if we start asking for it, now we can instantly find it, and it'll be okay. Okay. Do y'all want to try another sign one, or you figure you're pretty good? Pretty good. Okay. Fair. So then we'll go over. There's two more things we need to do with forces. We need to do. Oh yeah, I do need to give y'all the homework, don't I? Do y'all want to work on that? Is that what you want to do? Okay. Huh? When do y'all want it to be due? Tell you what. Let's actually look over it first, and then we'll find out whether or not we want to have it due Wednesday or Tuesday. Let's look because some homework assignments are easy, and some homework assignments are not so easy. So let's try it out. So I'm going to open the homework assignment, digital people. That's what we're going to start working on right now.